Well, good afternoon. Thanks for coming back. Today we're going to use some notes to look at how matter is classified. And since this is chemistry, and chemistry is the study of matter, that's what we need to know next. Alright, so we're going to start with a huge flow chart here. I'm actually just going to have you pause the video and copy this down, and then we'll talk about it for a few minutes. Now, take a look at matter. In general, it can be separated into two main groups. There are mixtures and there are pure substances. Now, the way that you decide between the two is to ask yourself, can the matter be physically separated? Can it be filtered out? Can you physically pick out the parts and separate them one from the other? Maybe kind of like Lucky Charms cereal. You've got the cereal and the marshmallows, and you can separate those with your fingers. If it can be physically separated by filtering or evaporation or distillation, then it is a mixture. If you can't physically separate it, then it's considered a pure substance. Now we're going to look at each one of those one at a time, but I want to go ahead and show you at the bottom of this chart, take a look at, there are two types of mixtures. When you ask yourself about a mixture, you have to think, is its composition uniform? Does it look the same throughout? If the answer to that question is yes, then you are looking at a solution or a homogeneous mixture. You know, the prefix homo means the same. If the composition is not the same throughout, then you're looking at a heterogeneous mixture. Remember, that prefix hetero means different. With pure substances, you have to think a little bit differently. You have to try and think, can that substance be chemically decomposed? Can you make it undergo a reaction and break it down into simpler substances? If the answer is yes, then you are looking at a compound. If the answer is no, you're looking at an element. Alright, so first of all, mixtures. The definition of a mixture is just a substance that is composed of two or more pure substances. So it could be two or more elements, two or more compounds, or some mixture of the two. Here are the two examples of the different types of mixtures that the flow chart showed you. Heterogeneous mixture, for example, would be like this granite. And a homogeneous mixture or a solution would be this glass of apple juice. You know, when you look on the carton of apple juice, there's not just apple juice in the container, but there are some other chemicals. You just can't see them in this sample. Now, on your guided notes, this question is already written down on the right side of the page. So if you'll just pause the slide, pause the video here, I want you to try and classify each one of these as homogeneous or heterogeneous mixtures, and we'll discuss them in class next time. Great. Now let's start talking about pure substances. There are elements, like in these pictures, there's a picture of copper wire and aluminum foil. Both of those are elements located on the periodic table, so I know they're made up of just one type of atom. Compounds, on the other hand, are composed of two or more elements, and they're bonded together chemically in a set ratio. Take this salt, for example. The formula for salt you probably already know is NaCl, sodium chloride. Sodium is one element and chlorine is the other element. The salt doesn't act like the sodium, it doesn't act like the chlorine either. It's its own substance, different from the elements that make it, and that compound has its own properties. Alright, so here's another practice set for you. On the right side of the paper again, these examples have already been put on your guided notes, so I want you to pause the video and see if you can classify each one of these as a compound or an element. Remember, elements are one type of atom, and you can find them on the periodic table. Compounds are combinations of elements. So good luck! Now, we've already talked about some of the physical properties of matter, and melting points and boiling points. Density and solubility are some others that we haven't looked at quite as much, but you are going to be doing lab activities for these, and you've got a lot of information in your reference tables about the physical properties of matter. So I want to go ahead and talk about them during this lesson. There are three basic states of matter that we have on Earth. There are solids, which on the left side of this slide are the red circles that are in close proximity with one another, and they're very ordered and arranged neatly. Well, if you take a solid and melt it, you're going to make a liquid. The liquid's the middle picture in this slide. You see the molecules are still pretty close together, but they're not quite as organized. And then finally, if you vaporize a liquid, you create a gas. Gas is the picture on the right-hand side of this slide. Gas molecules are spread very far apart and they're not organized at all. Now this whole process as you go from a solid to a liquid to a gas requires energy, so it's termed endothermic. Some substances go directly from a solid to a gas. That's called sublimation. You'll see that on the top of this slide. An example of a substance that sublimes would be mothballs or the air freshener that comes in those little cone-shaped containers that you buy from the store. They go from a solid to a gas directly without becoming a liquid in between. Now, the other thing about this slide is that you can go to the left. You can go from a gas to a liquid to a solid. You can condense a gas into a liquid, and you can freeze a solid, a liquid, into a solid. And you can do that by removing energy. And that process is called an exothermic process. You have to remove the energy from it. Just like when you want to make ice, you have to put the water in the freezer to remove the heat from it so that the water can freeze. Now, with these three states of matter, solids have a definite shape and a definite volume. It's not real easy to compress a solid. Liquids and gases, on the other hand, take the shape of their container. Liquids aren't very easy to compress, but gases are really easy to compress, and you just have to put some pressure on the gas for that to happen. Alright, so these last few slides, because you have so much information in your reference tables, I want you to look up the melting and boiling points of these compounds and these elements, and I want you to rank them from the smallest melting point to the largest melting point. Now these notes are already copied on your guided note handout, so you don't have to write all this down. I just need you to find the melting points in the reference tables and put them in order. So just pause the video for a few minutes while you complete that task. Alright, the next question with your reference tables. I want you to figure out what state of matter each one of these substances will have at a given temperature. Now I'm going to do the first one with you. I think about these temperatures as a number line. For chlorine, we are looking at chlorine at negative 25 degrees Celsius. You have to know what the melting point and the boiling point are for chlorine. And you want to figure out where negative 25 fits into that. Now based on that, like a number line, if chlorine is colder in this problem than the freezing point or the melting point, then you know it's a solid. If negative 25 degrees is in between the melting point and the boiling point, then chlorine is a liquid. And if the temperature of chlorine at negative 25 is warmer or beyond the boiling point, then you know chlorine is a gas for this problem. So pause the video, see what your answer is for each one of these, and we'll talk about it next time in class. Alright, and then finally, density is another physical property that you have a table for in your reference packet. This problem is in your guided notes, so one more time, pause the video and see if you can find the density values in the packet and rank these substances from the largest density to the smallest one. Good luck!